All right, checkpoint exercises for point slope form, standard form, and in this case slope intercept form. With number 1, we're given that a line passes through the point 4, -1 and has a slope of -3. So we're given a point, we're given a slope. For the point slope form, we just substitute into the equation y minus y1, which would be -1, equals m, our slope, -3, times x minus x1, which is 4. And then we go ahead and simplify that left-hand side to be y plus 1 equals -3 times x minus 4. And there's our point slope form. We're also asked to write this in slope intercept form. So we just solve for y. So first we'll distribute the 3, or the -3 rather. So y plus 1 equals -3x plus 12. Subtract 1 from both sides, we get y equals -3x plus 11. In number 2, we're given y minus 8 equals -1/2 times x plus 3, and we're asked to write that in slope intercept form and standard form. We'll go ahead and write it in slope intercept form first. We just solve for y. So distribute that -1/2. So y minus 8 equals -1/2 x minus 3/2. We'll add 8 to both sides, so plus 8 on this side, and we'll go ahead and make this plus 16/2 on this side since we're given 3/2. So y, because the 8's cancel, equals -1/2 x. 16 minus 3 is 13, so plus 13/2. Now we're asked for the standard form, so ax plus by equals c. I'll go ahead and write that out here. Ax plus by equals c. That's our standard form. So when we have our standard form, or to get our standard form rather, we need to know that a, b, and c are all integers. They can't be fractions or decimals. And to do that, we multiply, if there is a fraction, by the least common multiple of all of the denominators. So in this case, I'll go ahead and rewrite this. We have y equals -1/2 x plus 13/2. We have 2 as denominators, so let's go ahead and multiply everything by 2. So we'll get 2y equals -1/2 times 2 is going to be -1, so -x plus 13/2 times 2 is going to just be 13. If we add x to both sides at this point, we get x plus 2y equals 13. So there's our standard form. X plus 2y equals 13. So we're given point slope form, we found the slope intercept form, and then from the slope intercept form we simplified to get the standard form, or we algebraically manipulated to get the standard form. Alright, in number 3, we are given a graph and asked to find point slope form and slope intercept form. I went ahead and sketched a copy of the graph and identified the points that are given on the graph. And they are 2, 3, and 5, 5. So to find point slope form, we just substitute in our equation for using either point. So y minus y1 equals our slope times x minus x1. First we need to determine slope. So our slope, we'll use 5, 5 as our beginning point. So 5 minus the corresponding y coordinate in the other point, 3, over 5 minus the corresponding x point, which equals 2. So 5 minus 3 is 2. 5 minus 2 is 3. So our slope is 2/3. Now we'll go ahead and we'll use either point. We'll start with 5, 5 again. So y minus 5 equals 2/3 times x minus 5. Or we can use our other point, 2, 3. So y minus 3 equals 2/3 times x minus 2. And then we'll use both of these to put it into slope-intercept form. And reason being is because that way we can verify that they're both correct. So we'll start with the y minus 5. Y minus 5 equals 2/3 times x minus 5. Distribute the 2/3. Y minus 5 equals 2/3 x minus 5 times 2 is 10/3. Add 5 to both sides. And we'll go ahead and write this as 15/3. And that gives us y equals 2/3 x. And then negative 10 plus 15 is plus 5/3. Now we'll go ahead and use our other point to verify that we get the same slope-intercept form. So y minus 3 equals 2/3 times x minus 2. Distribute the 2/3. Y minus 3 equals 2/3 x minus 4/3. Add 3 to both sides. And we'll go ahead and make this 9/3. And then y equals 2/3 x plus 5/3. So we get the same slope-intercept form as we did before, and that helps to verify that the point-slope forms of our equation are correct.